Everyone, and welcome back to videos. I feel like it's been a long time since we've done a new lesson. You have completed what I think is probably the most difficult unit of applications of derivatives, and now we are on to the second part of calculus, which is integrals. And so with integrals, you're working backwards from what we have learned with derivatives. So if we look at this first one, given that f prime of x is x squared plus 3. What was the original function? If you want to pause it and try to do it, please do that now. But if we think about it, the derivative is when you bring down the exponent. And so if the original function was x squared, we know that this had to be x cubed, since 3 minus 1 is 2. And then you would have a 3 here, so what we need to do is divide by 3. So now if we think about it, the derivative of x cubed, bring down the 3, you get x squared, divide by 3 here, the 3's would cancel out, and you're left with just x squared. You take the derivative. Then if we just have a constant, we know that the derivative of a linear function gives you a constant, so 3x. And then what we don't know is if there was a constant at the end of this. So that's our original function. So what did we just do here? Well, you just took the integral. And so the integral, instead of subtracting 1, what are we going to do? Well, you're going to add 1. And then divide by n plus 1. And again, what we don't know is if there is ever a constant at the end of it. So you always want to make sure you have this plus c. Now, new notation here. So this is the integral, saying to do the opposite of derivatives. So you take the integral of x to the n. This is telling you what you're taking the derivative with, or the integral with respect to. And then this is your answer. So make sure that we know that the function f is called an antiderivative. And make sure you realize that there is a, you cannot see that, I need to change that, but there is a derivative sign there. So f prime of x equals f of x. And you can see it also written there. So let's look at some examples here. The integral of x squared, well, we just did that. Add 1, divide by what you added to, plus c. We look at this one. You already have a 3. We can bring that 3 out in front. And so we're going to get 3 times x to the 5th, added 1, divided by 5, plus c. So you can get 3/5 x to the 5th plus c. Again, you can bring the 5 out in front. It's the constant rule. Add 1 to 1/2. 1 plus 1/2 is 3/2 over 3/2. Now with this, make sure you understand that when you divide, we have a complex fraction here, we're really multiplying by 2/3. And so 2 times 5 is 10 over 3, x to the 3/2 plus c. Or you could have written that out as a square root of x cubed plus c. Either one. Either one would have been acceptable. With this one, I know I'm going fast, just pause it if you need to. We need to distribute. And when you do this, we can split up the integral. So you're going to get the integral of x cubed plus the integral of 6x squared dx. So we're going to use the same method, the same rules, same properties as derivatives. So we're going to get x to the 4th added 1 divided by what the exponent is, plus add 1, 6x cubed over 3, plus c, which that then equals x to the 4th over 4 plus 2x cubed plus c. This one, again, you could split it up if you wanted to, bring the 2 out in front. Make that to the 1/2. And so we're going to get 2, x add 1, make sure it's negative 2 divided by negative 2, minus x, we already did to the 1/2, you know that's 3/2 over 3/2 plus c. And so those twos will cancel. We'll get negative 1 over x squared. The negative exponent brings it down. Minus 2/3 x to the 3/2 plus c. And that's your answer. Oh, you can't see it though. Sorry about that. That's your answer. And the last one, we can make it the integral of 2x to the negative 4 minus 6x squared. The integral of that, make sure you have your dx's. And so we're going to add 1, 2x to the negative 3 over negative 3 minus, we just did, nope, we did not do 6x squared, never mind. Oh yeah, we did 6x squared right there, so 6x cubed over 3 minus the integral of a constant 4x plus c. You can put the x cubed on the bottom, and we're done there. So those are the basics. The basic ones. Same idea, it's just using the rule that we stated up here. Add 1 to the exponent and divide by what that number is. And if you think about it, if you take the time, think about it, it all deals with if you take the derivative of every single one of these, you should get the same result. Bring the 5 down, that would cancel the 5 here, and you'd be left with x to the 4th, you'd be left with 3x to the 4th. Hence the function that you're taking the integral of. And so you can do all of that if you wanted to. I'm going to ask you to pause this and finish what you can do for the first two, and then I'll have the answers and we'll look at the middle two as two properties that you already know, but I'll go over with you. And so here are the answers to the first two. Notice that either one of these answers are correct. I just made the 1/2 into a square root, and that should make sense. One thing that you notice, I did not write a 4c, and you do not need to write a 4c, just so you know. A constant's a constant, so you don't have to write 4c. If you had written 4c, it would not necessarily have been wrong, but you don't need to do that. Now, let's talk about this one. Most of you would say, well, let's rewrite as x to the negative 1 dx. And what's the issue with this? The issue with this is that if I add 1 to negative 1, I'm going to get x to the 0. If you did this, and you don't need to write this down, but you would get equals x to the 0 over 0, and hey, that doesn't work. So, can't do that, so let's erase that. And, well, how do you get 1 over x if we think of it? How do you get 1 over x from using the derivative? Well, you are correct if you were thinking ln. This is actually equal to the absolute value of ln of x plus c. You do need the absolute value in there. This one to the next one, bring the 4 out. What's the integral of e to the x? Well, the derivative of e to the x is e to the x, so what must the integral be? E to the x. So those are two properties, or two other special scenarios that do not use power rule. And then the last one, if you take the time to do it, you can pause it, but here's the answer for this one on page 2. Pause that. The next page deals with integrating trig functions. Do not get stressed out about this. You have all the integration formulas right here. They're exactly the opposite, of course, of what we learned with differentiation. So if we look at the first one, pull out the 7, the integral of cosine. Now notice it starts with a c, but we're doing the opposite, so that we do not change signs. So 7 sine x, the opposite of cosine and sine, plus c. Done. Now with this one, we got to be careful. We don't have 1 over cosine squared theta. We understand that. We have not learned yet how to solve anything that deals with a substitution. So how do we rewrite 1 over cosine? Secant. So we're going to look at secant squared theta d theta. And then we go back up and we say, oh yeah, secant squared theta is tan theta plus c. It's as simple as that. The last one here, you need to split up. And look at what happens when you have sine theta over cosine theta. The integral of tan theta. And what's 1 over cosine? We just talked about that. Secant theta. Hey, you look back up at the top, and secant theta, tan theta, is secant theta plus c. You got that in case you didn't see it from right here. And so you do need to manipulate trig functions to make them look something that you have, like you have in the boxes. But that's all it is. Just manipulate it and then find what the integral is. The very last bit is if you are given a constant to find the original function. So we always write plus c, but now we're going to give a constraint or an actual value of the original function to find what the constant is. So we're going to not worry about the 4, 3 yet, and we're going to take the integral of this. So the integral of x squared, x cubed, I could write a 3, nice, that would be good, plus 6x plus c. That's our original function. Now we got to find what c is. So we'll plug in, this is our x, that's our y, and so we'll plug it in. 4 cubed over 3 plus 6 times 4 plus c equals, again that's what y is, so equals 3. And now let's solve that. So we've got 64 over 3 plus 24 plus c equals 3. And we'll get negative 21 over, negative 21 equals 64 over 3 plus c. If we do all that out, we're going to get c to be negative 127 over 3. And so our final, the original function, we wanted to write it out, is y equals x cubed over 3 plus 6x minus 127 over 3. So one of the main things that I did forget on this one is that the implied symbols, because you can't have two equal symbols. But for the joke of the day, why did the stadium get hot after the game? Why did the stadium get hot after the game? All the fans left. Man, they're good ones. So the last one, find the original function when the integral of sine x dx and y sub 0 equals 1. So we're going to get y equals, the integral of sine x is negative because we're not looking at the derivative, we're doing the opposite, plus c. And so we're going to get 1 equals negative cosine of 0 plus c. Make sure that you remember the unit circle at 0 or at 1 comma 0. We're looking at the x value, so 1 equals negative 1 plus c. So c equals 2. And so our original function, y equals negative cosine x plus 2. And we are done. Hope that made sense, and we'll see you in class.